Hi, welcome back to another video. Today we're going over a A2 physics question. So I saw the question and many people were confused by it, so I thought I'll run over this and hopefully this helps. So basically, to sum up the whole question, we just need to prove that the delta EP is the same as mgh on a small distance. And maybe people were confused because halfway through the thing, you had to make an assumption. So we know that our delta EP is just the delta of gravitational potential times mass. And we can rewrite delta gravitational potential as Gm over R1 minus Gm over R2, and then we haven't done anything with m, so times m. And obviously we can simplify as Gm bracket R1 over 1 minus 1 over R2 times m. So here's where most people get confused, because we have to make an assumption here. So since it's a small mass moving near to and normal to the surface of the planet, we have to kind of assume that R1 is roughly the same as R2, which means that we can rewrite this as Gm bracket R2 minus R1 over R2 R1 bracket times m. And then we put this assumption in, which means that it's Gm over, and then R2 minus R1 is the height, right? So the change is just R2 over R1, which is the height change, so it's h over r squared times m. So now we get this little function. Well, we can now expand this bracket, so working back over here, we can make this over Gm over r squared times mh. And we know that Gm over r squared is g. And we can prove that because we know that F equals to mg, right? And we know that F equals to g m over r squared. So if we plug this back over here, we get just g equals to F over m, by the way, which means that it's g m over r squared divided by m, and that will give you g m over r squared, which is why small g is the same as Gm over r squared. So we can rewrite this part as Gmh as delta EP. And obviously that is just the same as mgh. So this is why maybe people get confused, because we have to make this assumption right here, that R2 is around the same as R1. So just remember that if the distance is small, so if delta h, or let's rewrite distance, is small, we can make this assumption right here. So I think the key point to take away from this question is simply this point right here, because once you get this point, you can work out everything, and it's pretty easy. So I hope this helped, and good luck on your exam, and I'll see you later.